Hey everyone, welcome back to TechBit Academy. Please like this video and subscribe to the channel.
You know that feeling when you're filling out some massive online form or maybe trying to book a flight and, oops, you accidentally click the wrong thing? In that split second of total panic, have you ever found yourself desperately wishing for an undo button in real life? We've all been there, right? The sheer frustration of bad digital design is just the worst. But think about the flip side. Think about when things just work perfectly. When an app feels like it's literally reading your mind, and you always have this neat little emergency exit when you mess up. Well, spoiler alert, that doesn't happen by accident. Welcome to today's Explainer. We are pulling back the curtain on the invisible rules that dictate those seamless user experiences we all love. We're going to explore the exact framework that turns frustrating digital mazes into smooth, intuitive journeys. Seriously, by the end of this Explainer, you're never going to look at your favorite apps the same way again. So, here's our roadmap for today. First up, we'll ask, what actually is heuristic evaluation? Then we'll dive right into 5 key principles: visibility of system status, matching the real world, user control and freedom, consistency and standards, and finally, the art of error prevention. Let's get into it. All right, starting with Section 1. What is heuristic evaluation? The debugging framework. So, at its core, heuristic evaluation is basically an expert review process. It was proposed by Jakob Nielsen and Rolf Mullich, and it's a method used to, quite literally, debug a user interface design. Think of it like a safety inspection for a building, but, for software. Experts come in and examine a design against a set of identified usability criteria, those are the heuristics, just to see if the system violates any predictable, consistent behaviors. Basically, they're looking to see if the system gives proper feedback and actually behaves the way a human brain expects it to. In practice, this evaluation is a super clean 4-step process. First off, you choose your evaluators, which is usually a small group of experts. Second, you identify and define the main goal of the website or app. Third, you define a specific set of tasks for those evaluators to actually perform, something like, say, adding an item to a shopping cart. And finally, you just perform the evaluation, judging absolutely every step against those heuristics. It's a real game changer because it turns this vague, abstract feeling of an app being clunky into a concrete, repeatable debugging method. Moving right along to Principle 1, visibility of system status. The big idea here is that the system should always keep users informed about what is going on. It really has to provide appropriate feedback within a reasonable amount of time. I mean, you should never be left wondering if an app actually registered your tap or if your phone just totally froze. Have you ever clicked submit on a payment form and nothing happens? Just radio silence? That knot of anxiety you feel right then? Yeah, that is a direct failure of this exact heuristic. And there's actually hard data behind our patience, or lack of it. Human attention is incredibly measurable. Get this, if a system responds in 0.1 seconds, no special indicators needed at all. It just feels instantaneous to us. But at exactly 1 second, the user starts to lose track of the data and actually notices the delay. And if an operation takes 10 seconds, wow, that is the absolute maximum duration a user can stay focused on an action. For literally any delay longer than that, designers are absolutely required to use %done progress bars just to keep the user anchored. This is exactly why things like step wizards, loading spinners, and those percentage progress bars are so absolutely crucial. They actively map out the system status for us. They essentially whisper to the user, hey, don't worry, I'm working on it, and here is exactly where we are in the process.
All right, next up is Principle 2, matching the real world.
Look, good design shouldn't force you to learn machine code, right? The system should speak the user's language, using words, phrases, and concepts that are entirely familiar to us. It actively avoids technical jargon, unless, of course, the specific audience is highly technical, and it presents information in a logical, natural order. Essentially, the user should never, ever feel like they need a translator just to navigate a digital space.
Just think about the icons we use every single day. We use a trash can for deleted files, a blue manila folder for directories, a physical address book for contacts, a compass for a web browser. I mean, we literally drag digital files into a digital trash can because it perfectly matches physical, real-world logic. It's brilliant, really. It makes navigating the abstract digital world feel as familiar as organizing your own physical desk.
Let's look at Principle 3, user control and freedom.
The core rationale here acknowledges a very simple truth. Users inevitably click the wrong thing. It happens all the time. when they choose a system function by mistake, they absolutely need a clearly marked emergency exit to leave that unwanted state without having to jump through hoops or go through some massive extended dialog box. This means heavily supporting undo and redo capabilities. Users must never feel trapped inside an application.
Gmail's famous undo prompt is honestly the ultimate example of this. Have you ever sent an email to the wrong person, or even worse, hit reply all when you definitely shouldn't have? Ouch. That little yellow box with the undo link is the ultimate expression of user control and freedom. It gives you this brief, magical window to reverse a high-stakes action, instantly relieving all that user anxiety.
Similarly, if you accidentally hit cancel while typing out a really long Facebook update, the system doesn't just instantly wipe your work. It stops and offers a safe exit, asking, discard post, discard, or keep. This simple little prompt really drives home how essential these safe exits are across all major platforms to protect our time and effort. It's a lifesaver, for sure.
Moving on to Principle 4, Consistency and Standards.
The golden rule here is super simple. Don't reinvent the wheel. Users should never have to wonder whether different words, situations, or actions mean the same thing. UI components and terminology must be incredibly consistent throughout an application so the user doesn't have to constantly relearn the interface on every single page. It's all about reducing that cognitive load.
Consider the contrast between following platform conventions versus, just reinventing the wheel. Think about a standard hyperlink. By established platform convention, a hyperlink is usually text that is blue and underlined. If a designer suddenly decides to make their hyperlinks neon green and flashing just for the sake of being different, well, they aren't being innovative, they are literally just confusing the user.
If you compare the classic Facebook like button to the old Google +1 button, it shows exactly how interactive elements and branding create standards of trust. When you break these consistent choices and change up the language, you force the user to pause and think, which completely breaks the flow of the experience. Good design relies on familiar standards, period.
And finally, Principle 5, the art of error prevention.
So while polite error messages are definitely nice to have, what's even better is a careful design that actually prevents the problem from occurring in the very first place. You can do this by either completely eliminating error-prone conditions, or by actively checking for them and presenting users with a confirmation option before they commit to a dangerous action. The true art of design here is predicting human error before it happens.
We actually see this kind of error prevention in our everyday lives all the time. For example, if you type "I have attached" in a Gmail message but totally forget to attach the file, it actively stops you. Meanwhile, Google Search uses autocomplete to suggest correct terms, reducing bad input before you even hit enter. It basically uses the computer's vast memory to compensate for our own human limitations.
So, we've just walked through 5 key heuristics: system status, matching the real world, user control, consistency, and error prevention. And remember, these aren't just technical rules, they are actual psychological safety nets. So the next time you use your absolute favorite app and everything just flows perfectly, ask yourself, is the design invisibly guiding you at every step, or are you just lucky? Thanks for joining me on this explainer, and keep looking for that hidden design all around you.